In today's video, we are going to solve the number of islands problem from LeetCode, which is a very popular graph traversal problem. In our previous lessons, we learned how to traverse a graph using the two popular traversal algorithms, which were breadth first search and depth first search. And today I will use breadth first search to uh, solve this problem from LeetCode. So here the given problem is that given an m by n two-dimensional binary grid which represents a map of land and water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally and vertically. You may assume all four edges of the grid are all surrounded by water. So this is actually an array, a two-dimensional array from a programmer perspective. But this array represents a map that in this array, every number 1 represents a land, a piece of land, and every number 0 represents an area which is covered by water. So now we have to find the number of islands. For example, here, what does it mean to find number of islands? First of all, you know that island is a piece of land surrounded by water. For example, this one is an island, this one is an island, and this one is an island. There are 3 islands on this map. So now the question is that how do we count the number of islands? So it is an array. We already know how to work with array. Someone may easily think without much further thinking about this that, well, let's go through all indices starting from first row and count all number ones. But that doesn't give us the correct answer because that way you may be able to count how many number 1 you have on this map, which is 1, 2, 3, 4, 5, 6, 7. You may come up with the result of 7. But if you want to prove it as an island, there are some conditions that all the adjacent or neighboring number 1 adjacent land, they are considered as one island. For example, this 4 number 1, they are one island. This is another island, and this is another island surrounded by water. In total, we have 3 islands. So now it is the time that we need to use our knowledge of breadth first search or depth first search in order to search all adjacent number 1. For example, here when you come at this point, so here you should be able to search all number 1 which is connected to this one, because they are all considered as one island. And this way here it is already one number 1. But when you come here, also when you come here, you should be able to traverse or search all adjacent number 1s. So for that reason, we can use either breadth first search or depth first search. And today I will use breadth first search to solve this problem and count number of islands. So let's write the code. First we need to have a counter or variable just to keep the number of islands. Let num of islands by default it is 0. So now let's start iterating through this array starting from index 0. And you know that there's a two-dimensional array, so we need a for loop for let row equals 0 from first row, and it continues until row is less than grid.length and row plus plus Also we need to go through each column as well. For let column equal 0 and column continues until grid 0 dot length and column plus plus. So if someone got a question that why I chose grid 0, that means have a look at this matrix, you will get this why. It is a two-dimensional array that this array, every element is also an array. So when you process the inside array, so you need to get the length of that array which is inside the bigger, inside this array, inside the bigger bracket, outer bracket. So for example, this is an array, this is another array, this is another array, this is another array, this is another array, and there are 4 arrays. That means this matrix or this array has 4 elements, which each of them is an array as well. So for that reason, I need to get the length of this array. And how can I get this? I'm saying grid 0, get the first element of this array and check its length, which is at this point, for example, 1, 2, 3, 4, 5. The length is 5. Okay. So while we are traversing this matrix, we say that whenever we come to a number 1, if grid row and column equals number 1, be very careful that the number 1 and 0, they are all strings or characters. So you say whenever the row and column become number 1, that means that should be considered as an island. So the number of islands should be increased. Num of island plus plus. However, the tricky points starts here. So now that you start from here, it is a number 1. So you say, okay, it is an island. However, when you go to the next index, it's also number 1. So do you think it's a separate island? No. It is just a piece of another piece of land located next to this one, which they are all considered as a whole island, because we know that an island is a piece of land which is surrounded by water. So in order to consider all these adjacent number 1 also, here is the time that we need to use the breadth first search and check all its adjacent land and consider all of them as a whole island. So now let's create a function BFS and pass this row and column, because we want to look all adjacent land to this index. So pass the row and column that here we got, it was number 1. So now let's define our BFS here. Const BFS equals, it gets 2 parameters. The first one is the row and the second one is the column. Okay, so whenever you want to implement a breadth first search, the first thing that you need is a queue. Let me have a queue here. Let's say it is a queue. So create a queue, const queue equals, and at the beginning add the starting point to the queue, which is the row and column, and as far as for each of these index we have 2 points, the row and column, so we add all of them as an array inside this queue, row and column, like this. Row, column, like this. because that should be, it should be like this inside this queue, and we keep adding uh, at the in it is a queue. So if it is the first one, after this one, like we add the second one here, the second one here, and all of follows the first inserted element. So now the second thing about the breadth first search was that we need to have some approach to be able to keep track of visited nodes in order not to visit them again and again. So in previous lessons, we were creating separate list, and then we were adding all the visited nodes into that list. However, here, when you look at this matrix, you can use your creativity, and here you can make it even easier. That approach also works. You can create a separate list of visited nodes and then add every index into that list of visited nodes. But that takes extra time, and that needs more process, more times, more calculations. However, there is another easier way. Here the whole point is that all these adjacent numbers 1 should be counted as one island. That is the whole point. So if that is the whole point, what does that mean? That means we have to make the rest of the number 1 0. If there is only 1 and the rest is 0, that means the number of islands get increased only once. For that reason, when we do the breadth first search starting from this index, we make all its adjacent elements 0. So when we make them 0, that is the time that the number of islands does not get increased, and it gets increased only 1 as far as all the number 1 are adjacent to one another. So anytime that you visited an index, you make them 0. So right now here, row and column that we have already visited here, and we increase the number of islands. So now we have to make it 0. Greedy row and column equal 0. Okay, this way it is marked as visited. So next time, for example, just in case you come here, because for example, if you are here, or if you start from here, not here but here, because we do not consider the diagonal neighbor right now. If you start from this or this, so it is considered a neighbor to this one. So as it is already made 0, and that means we do not increase the number of 1, so that's considered as a visited node. So for that reason we make that 0. So now we have to start processing all its neighbors. So we made that 0. Now let's start processing its neighbors, and we say that as far as q is not empty, q.length length is greater than 0, we have to keep processing it, and every time we have to remove the first inserted element and get its neighbors. Right now this node is inserted in the queue, so let's remove this. And you know that there is every element in this queue is as an array, row and column. So we need to spread into 2 variables. One should be row and one should be column. So I get here row and column equals q dot shift. So once this one is removed, that right now we remove this here, and we got the row inside this r variable and the column inside the column variable, the c. So now at this point that we remove this node from our queue, we have to get all its neighboring elements, neighboring nodes. So let's get all the neighboring nodes, and for that we need to have a separate functions that would be much easier. Let neighbors equals, so I create a function and name it get neighbors. GHBORS get neighbors. So pass this row and column to this function, and when you define this function, so you get this index. Now consider all its adjacent or neighboring nodes. Let's define this get neighbors also. Const get neighbors equals, so here we have row and column. Okay, so here when we are looking for its neighbors, let's create an array and keep all the neighbors inside that array and then return that. So let all neighbors equals, now it is empty, so we need to have the upside neighbor, we have to find the down neighbor, we have to find the left neighbor, and we have to find the right neighbor, and at the end we return the all neighbors. Okay, so now get our up neighbor. See here, if you are on the first row, automatically you know that there is no up neighbor. But if you are on other rows except the first row, that means you have an upper neighbor. So easily you can check. You say that if row is greater than 0, then this has an upper neighbor. Otherwise it doesn't have a neighbor if it is on the first line. However, here you check this one and also consider another condition. You are looking only for those neighbors which are number 1, not 0. So if they are 0, you do not care about them. But if they are number 1, that means you have to make them 0. So you need to get that. So you say if row is greater than 0 and grid the row minus 1, its previous row. For example, let's suppose you are on the second row, that is row is greater than 0, and also its previous row minus 1 on the same column is equals to number 1. If it is to number 1, then that is a neighbor that we are looking for, and we need to add this to the neighbor array. All neighbor dot push row minus 1 and column. Okay, upper neighbors are added this way, and down neighbor. So when you look at this matrix or this array, if you are on the last row, that means you don't have a down neighbor. But if you are on other rows, that means there is a possibility of you have a down neighbor, and also you are looking for those neighbors that are number 1, not any neighbor. So there are two conditions. First, you say that if row is less than grid dot length, length, it should be less minus 1. Now, why is that? Because the length of this grid is 1, 2, 3, 4. It is number 4. However, you should remember that this row and column, they are the index, and we know that we started our index from 0. So for that reason, I said minus 1. And why grid.length minus 1? Because grid.length is 4. So if we start index from 0, so it is 0, 1, 2, 3. So the last row, which is index 3, it is also less than 4. So it gives us the wrong answer. For that reason, I said minus 1, so that 0, 1, 2. 3. Now it is 3. So we say that the row should be less than 3, which is 0, 1, 2. Until here, we can have a down neighbor. But if we are on this line, that means we do not have a down neighbor. And also there is another condition that we are looking for, that we say that grid on the row plus 1. For example, if you are on this line, on this row, so it's, and you are now looking for the down neighbor. So for that reason I'm saying that row plus 1 on the same column, it is equal to number 1. Then that is a neighbor that we are looking for. Then add this to the all neighbors. All neighbors dot push row plus 1 and column. Okay, now get our left neighbor. So left neighbor, also look at this matrix. If you're on the first column, you don't have any left neighbor. But if you're on other columns, then you have a neighbor. So you look for, you say if column is greater than 0, then you have a left column, a left neighbor. And as far as we are looking for also another condition, that we are looking only for those neighbors, which is number 1. So for that, then I check the second condition also. I'm saying that all and grid column minus 1. For example, if you are on the second column, that means you have a left neighbor. So you say that when you are on the second, it's previous column, the previous column, but same row. Equals number 1. Then that means that is the neighbor that we are looking for. So add this also to the neighbors, same row and column minus 1. So now let's get our right neighbor. So right neighbor, also if you look at this matrix, if you're on the last column, you don't have a right neighbor. But if you're on other columns, then you have a right neighbor. So you say that when you are looking for the right neighbor, it should be always less than the number of last column. For example, you say if column is less than grid 0 dot length length minus 1. So grid 0 means this array, and this array dot length is 1, 2, 3, 4, 5. So why minus 1? Because we are, this row and column shows the index. So if it is 5, then minus 1 becomes 4. For that reason, index 0, 1, 2, 3. So you can have a right neighbor as far as you are until going to the index 3. But if it is 4, that means that is the last column and there is no right neighbor. So for that reason, you check up until the second last column. So minus 1, and second condition, that grid at the row, at the same row but column plus 1. For example, when you are here, you are looking for its next column but on the same row. So if this condition meets that it is equals to 1, then that means that is a neighbor that you are looking for. So now add this also to the neighbors, neighbors dot push, so same row but column, next column. Okay, and now you return all the neighbors. So here when you process this node, you have one right neighbor, this one you have added to the array, and down neighbor, this one. For example, right now you added this two, That means if you return these neighbors, you have two values. So when it comes here, the neighbor brings two value at the first process. So, and it is also an array, and every array has two elements that both of them has a row and column. They are also an array. So for that reason, now you have to go through each element in this array that right now it has two elements. So you have to go through each of them and make them 0. So we got two neighbors here, so now we have to go through all of them. Say for let, so here you know that every neighbor is stored as an array of row and column. So we spread them here to neighboring row and neighboring column of neighbors and you make them 0. So you say that, well, for example, if you are getting this first, here down, which, so it is added first, so now you are here, for example, so you make this 0. Okay, so you say greet at this neighboring row and neighboring column equals 0. So when you made this 0, then now you add this index to the queue, so that you should keep continuing checking all the adjacent number 1. So now it has made 0, but now this, add this index to the queue, so that if it has some neighbors, because it has one here. So now add this to the queue dot push. So queue dot push the neighboring row and neighboring column. Okay, so now this keeps progressing until the last neighboring nodes, as we have already studied how the BFS works. And when this gets end, that means we have get the number of islands, and at the end we have to return the number of islands. For example, so when we called this BFS on this one, and then we went to this BFS and made all its adjacent neighbor 0. So now this loop continues up until here. So when it comes here, again number of islands get increased by one more. Now it becomes 2, and it calls BFS, and we pass this index. So when we pass this index, this row and column, when it checks the neighbors, it gets nothing. All of them are 0, because we said while checking the neighbors that we should the row and column should be 1, but they are all 0, so the neighbor gets 0. And here also we do not return anything, so that means this loop continues and it comes here. So when it comes here, again number of islands get increased by one more, and it calls the BFS function on this. So when the BFS is called on this one, so here we only get one right neighbor, and we make that also 0, and the process finishes. So we return number of islands, return num of islands. Okay, so that's it. Now let's run this and see how it works. Okay, line 49 in solution.js, return number of islands. Number of island is not defined. Okay, num of, here, islands. Okay, here you can see that both the test cases are passed successfully. I hope you understood how it works, how we could utilize BFS to make all the neighboring land as mark them as 0 and then consider them as a 1. That means increase the number of islands by 1 using the BFS. Similarly, you can use DFS also. However, if you have any questions, add them in the comment section. I will uh, uh, go through your comments and answer your questions. Until the next lesson, have a nice time.